So today we're looking at graphs of rational functions. And so a rational function, here's a fancy definition for it. It's when we have f of x, so that's my function, equals p of x over q of x, where p of x and q of x are polynomials, basically exactly what we've been seeing, and q of x cannot equal 0. Why could q of x not be equal to 0? You can't divide something by 0. You cannot have 0 in the denominator. And a lot of what we do with these graphs is going to be based on what would cause us to have a 0 in the denominator. All right, and so there's a few special parts of graphs that we're going to see. And the first thing is called asymptotes. And an asymptote is a vertical or horizontal line that a graph approaches. Approaches means it gets close to, but it never actually touches. So your graph gets really close to one spot, but it never actually hits that line or crosses over it. And so we're going to look specifically, now there can be diagonal asymptotes, but we're only going to look at vertical and horizontal. So to look at a vertical asymptote, so a vertical line, a line that goes up and down, we have to completely factor the numerator and denominator. So we factor the numerator and the denominator. So any factor that is in the denominator but is not in the numerator. So if I have like an x plus 2 in the denominator, but there is not an x plus 2 in the numerator, you set that equal to 0. And that gives you your vertical asymptote. Now a horizontal asymptote, you look at the degree of the numerator and the denominator. If the numerator degree is less than, so if we have like x squared in the numerator and x cubed in the denominator, so a smaller degree up top, then our horizontal asymptote is at y equals 0. This is the x-axis. If the numerator degree is larger, so if we have an x cubed up top, but only an x squared in the bottom, there is no horizontal asymptote. If the degrees are equal, so you have x cubed and x cubed, we divide the leading coefficients. So we're going to do some examples so you can start to see this. So number 1, to identify our vertical asymptotes, and we'll get to actual graphs and you'll see what these look like in just a minute, we have to completely factor. So in the numerator, is there a GCF? No. Is this a difference of squares? Is this a trinomial? No. The numerator you cannot factor at all. What about the denominator? Does it have a GCF? It's a trinomial. So we can find two numbers that multiply to be -2 and add to be +1. Multiply to be -2 and add to be +1. What are those two numbers? -1 and 2. So x minus 1, x plus 2. So for a vertical asymptote, we look at the factors in the denominator. Do either of these factors cancel out? No, neither one of those canceled. So I set both of those equal to 0. So x minus 1 equals 0. So x equals what? 1. So one of the vertical asymptotes. So there's a vertical line at x equals 1. If I were to graph this, my graph is never going to touch that vertical line. And then x plus 2 equals 0. So x equals -2. And then our horizontal, look at the degrees. The degree is the largest exponent. So my degrees are actually the same. So I'm going to take this 2, and this would be a 1, and we do 2 divided by 1 is 2. So it has a horizontal asymptote at y equals 2. I'm going to show you what this graph looks like. So this would be -2 right here, this line, and this line would be +1. So those graphs never actually touch. So the farther this goes up, it actually is not going to cross over this vertical line. And then we have this horizontal line, they're not actually going to cross over that. So these graphs are going to look kind of funky. And pretty much these are going to be the only questions you have on the test, like what are the vertical asymptotes? And I'm going to give you these rules on the test, so you won't have to have those memorized. All right, number 2, let's factor this one. Nothing happens with the x plus 3. How does the bottom one factor? X plus 3 and x plus 5. Does anything cancel in these? The x plus 3's cancel. So when I'm doing my vertical asymptotes, the only one that I set equal to 0 is the x plus 5. So x equals -5. So the horizontal asymptotes, we look at the original problem. Are the degrees the same? No. The numerator degree is only 1. The denominator degree is 2. So when the numerator degree is less than, we have one at y equals 0, or you could say the x-axis. Now these lines right here technically go up, but for some reason, sometimes these asymptotes, the calculator can't draw that line in. So this one does keep going up, but it never touches this vertical line that goes through -5. So that's what we're looking at there. And then it does look like they touch the x-axis because the calculator can only be so accurate. But if we were to zoom really far in, it actually does not touch the x-axis because we have a horizontal asymptote there. And let's look at number 2. Start by factoring it. How does the numerator factor? We want two numbers that multiply to be 5 and add to be 6. X plus 5, x plus 1. 5 and 1 multiply to be 5. 5 and 1 add to be 6. What about the denominator? What does it have? It does have a GCF of x. So imagine that you take one of those x's away. We need two numbers that multiply to be -5 and add to be +4. What are those numbers? 5 and -1. X plus 5, x minus 1. And these x plus 5s cancel out. So for your vertical asymptotes, we have to set the x equal to 0 and the x minus 1 equal to 0. And so we get vertical asymptotes at 0 and 1. What about a horizontal asymptote? It's at y equals 0. If you look at the degrees, the numerator degree is less than the denominator because 2 is less than 3. So it's at y equals 0, or the x-axis. And again, I won't give you this exact thing right here, but I will give you basically that on the test. Now there's one other thing that we have to learn is holes in the graphs. So a hole is basically what you think it is. It's a point where there is a break in the graph. There's a hole there. Like it's like your line goes and then it jumps and then it keeps going. So there's a break in the graph. A hole occurs where there is a common factor. So for example, if I look back here at this, well, it should have been number 3. The ones that we cancel out, that's where there's a hole. Okay. And sometimes on your calculator, you can't really see it because, again, your calculator is only so accurate. So to find the hole, to find the x-coordinate, we set the common factor equal to 0. And then to find the y-coordinate, whenever we simplify our graph, we plug that x back in, and that tells us our y. So number 4, these are the same as these back here. Okay, so this first one, when we did this one, we got 2x squared plus 5 over x plus 2, x minus 1. Did we have anything cancel out on this one? So there are no holes because nothing canceled. On number 5, when we factored this one, we had x plus 3 in the top, x plus 5, and x plus 3 in the bottom. So I'm kind of going fast on these because we've already went through these problems. And we canceled out the x plus 3's, which makes this 1 over x plus 5. So this one is going to have a hole. To find the x value of the hole, we do x plus 3 equals 0. So the part that actually canceled is what we set equal to 0. And so we got x equals negative 3. And then for the y, we do 1 over negative 3 plus 5. What is that? Negative 1/2. No, it would be positive 1/2. Yeah, I just had it wrong on here. Yep, 1/2. So we have a hole at negative 3 1/2. So I don't know if we, is that this one? Zoom. I'm going to do Zoom Box. When you go to Zoom Box, you can kind of zoom in a little bit wherever you want. So it doesn't show it on here. A lot of times the calculator won't show those holes. And number 6, this one we did x plus 5 x plus 1, x plus 5, x minus 1. So then I just rewrote that without the x plus 5s. So this that was crossed out, basically think we're taking that out of the function. So that is a whole because we're removing it from the function. So my x value, I'm going to do x plus 5 equals 0. So x equals negative 5. And the y value would be negative 5 plus 1 over negative 5 times negative 5 minus 1. Just type that in your calculator. And what do you get? That, yeah, I'll say that's really not good. That's what I had, and then I thought maybe I messed up again. So it is negative 2/15. So we have a whole at negative 5, negative 2/15. So we're going to look at some graphs and just do several of these examples. One thing that we have not done, let's see, is X-Intercepts. So for the X-Intercepts, we set the numerator equal to 0. And that's how we find the X-Intercepts. So number 1, f of x equals x minus 4 over x plus 4. And we're going to find all of these things first, and then we're going to look at the graph and try to graph it on our paper. So X-intercepts, I'm going to do first. Now this is completely simplified. There's no factoring that needs to be done in either the numerator or denominator. So we don't have to do any of that. So I'm going to take the numerator, x minus 4, and set that equal to 0. So x equals what? 4. So this is the point where it crosses the x-axis. So I'm going to put that right there. Then we're going to do a vertical asymptote. So I'm just going to put VA, vertical asymptote. Now that's where we look at the denominator, and any factors that don't cancel, that's what we set equal to 0. Well, nothing canceled here, so x plus 4 equals 0. So x equals -4. Now, vertical asymptotes are they're imaginary lines. So I'm going to put a dashed line going through -4. So my graph is never going to touch this green line. The horizontal asymptote. That's where we look at the degrees. Are they the same? The degrees are the same. They're both just x. X to the first, x to the first. So when the degrees are the same, we divide the leading coefficients. So the number in front of the x. So we do 1 divided by 1, which is 1. Because neither one of those actually had a coefficient, so they were 1s. So we have a horizontal line that goes through 1. Holes, that's where we have factors that cancel. Did we have any factors that canceled? No, so there are none. So let's look at this in our calculator. Oops. Hold on. That's kind of the shape of the graph. So I've got right here, kind of makes a backwards L. And then one in this corner. But it does cross the x-axis at this point. So that's what the graph looks like. Not on these, no. Basically, if you have an X-intercept, I want you to show it going through that. If there is a hole, we'll show it going through that hole. And we're not going to do all of these. All right, so let's move on to, let's go to number 4, and then if we have time, we may backtrack and get some of these others, but I want to try to make sure we're seeing several different kinds of examples here. And you're going to be practicing this a lot tomorrow. So number 4, let's go ahead and factor and simplify this, because we'll need to do that at some point. So the x plus 5 doesn't do anything. But how can I factor the denominator? X plus 5, x plus 4. Because 5 and 4 multiply to be 20 and add to be 9. And so these cancel, leaving 1 over x plus 4. Now the first thing that we did was X-Intercepts. And when we're looking at the X-Intercepts, we're looking at the simplified version. This one right here. And what I showed you on the last problem was to set the numerator equal to 0. Well, there's no x left in the numerator at all when it's simplified. So there's actually no x-intercept. And you should be able to see that when we put it in the graph. So some of these things, like these asymptotes, if you are totally clueless, you could just look at the graph and take a really good guess based on where your graph doesn't cross at. Okay. The vertical asymptotes, those are where in the denominator we had a factor that did not cancel. So I had this x plus 4 that did not cancel. So I'm going to set that equal to 0. So that's a vertical line. It's an imaginary line. That's why I make it dashed. That goes through -4. Then we look at the horizontal asymptote. This is where we look at the degrees in the original problem. Are the degrees the same? No. This one, the degree is 1 because my largest exponent is 1. In this one, the degree is 2. So the numerator degree is less than, it's smaller. So when that's the case, it's at y equals 0. And then we do the wholes. Did we have factors that canceled out? Yes, the x plus 5s canceled. So that's a whole. So first we set the x plus 5 equal to 0. And we get x equals what? -5. And then for the y, we're going to plug it back in here. So 1 over -5 plus 4. You should get -1. So we have a whole at -5, -1. So I'm going to draw an open circle there to show that that is a whole. And so when I look at this graph, can you see the hole on this side? This time you should be able to see there, it just had a break in the graph. So that's what a hole is. So it looks something like this. The big things, make sure that your line does not cross over those asymptotes. And make sure that it goes near that hole. I mean, they're not going to be perfect. You're actually, on the test, you won't actually have to draw a graph. I think it just helps to visualize what a hole is a little bit. And what we're doing is just a very brief overview of these things. Like advanced topics and stuff, you get into this in a little bit more depth. Let's do number 5. The graph for number 5 is kind of cool. So number 5, let's go ahead and factor. What about the numerator? Can we do anything with that one? They have a common factor, a GCF of x squared. So when we factor out x squared, we're left with x plus 3. And then in the denominator, we need two numbers that multiply to be -3 and add to be 2. 3 and -1. So x plus 3, x minus 1. And then these will cancel out, leaving us with x squared over x minus 1. So X-Intercepts, we're going to set the simplified numerator equal to 0. So x squared equals 0. How do I get rid of a squared? Square root. And what's the square root of 0? 0. So x equals 0. So it's going to actually cross through the origin. Then the vertical asymptote. That's what we do with the simplified denominator, or any factors that did not cancel. So we have x minus 1 equals 0. So x equals what? 1. So this is the vertical line that goes through 1. A horizontal asymptote. That's where we look at the degrees. Are the degrees the same? No. This one has a degree of 3. This one has a degree of 2. So the numerator degree is larger. It's greater than. This was the one where we had none. And then holes. We only had one thing canceled out, so there's only one hole. So for the x value of the hole, we set the part that canceled, the x plus 3 equal to 0. And we get x equals what? And then for the y, we go to this and we plug in -3. But if you don't put that -3 in parentheses, you're going to get the wrong answer. You could also use your store button here. And you should get -9/4. And that's a little bit over -2. So if you just go to -3 and just a little bit past -2, that's close enough. And we're almost out of time. X cubed plus 3x squared over x squared plus 2x minus 3. So this one actually has an asymptote that's diagonal. But we're not doing any of those. So just kind of graph that in the best that you can. And this one you really didn't see the hole either. But we've got to cross that. Something like that. That's what it looks like. Just the best that you can. And we're going to practice. We're going to do several more examples tomorrow with these graphs.